1c, multiplying radical expressions. So let's take a look at how we do that. Well, first of all, we need to remember how we multiply to begin with. So what we're going to do is we're going to review how we multiplied polynomials. We use the exact same operations when we multiply radicals. So multiplying polynomials, we can do it two ways. We can do the distributive property, where we take the numbers and the variables in front, and we multiply them into everything on the inside, or we can make an area box, which you like best. So I'm going to take the 2x on the outside and multiply it to everything inside. And what I can do is I can draw it in a little box if I like. So I'm going to put my 2x outside, my 5x, and my negative 2x squared. They each get a box top. Okay? Now when I multiply, their answers are going to go inside those boxes. So I like the box strategy for the simple reason that if you miss a box, you know you've missed something, okay? All right. There's hidden ones on my x's there. So when I multiply variables, I add their exponents, and I multiply the digits in front. So I'm going to multiply those two numbers, and then I'm going to take the exponent x1s and x1s and add them. So that's going to give me 10x squared. The next one, I'm going to take negative 2 times my 2 to give me a negative 4. And I'm going to take my x2 plus an x1 to give me x cubed. That would be my final answer. Now I can rewrite it out of the box. My final answer being 10x squared minus 4x cubed. Okay, we are done. That's how you would simplify that question. You guys try number 2. Push play when you're ready. Okay, you've got a couple minutes to look at that. One thing we have to remember, stick all your little baby ones on, just so you don't forget them. So I've got my 3xy. It's going to sit out front of my big box here. And up top, I'm going to have a negative 2x, and I'll have a positive 3y. Now I multiply into the brackets. I get negative 6. There's 2 x's, so I have x squared. And then I have my y to the 1 by itself. Over here, I've got y1, and I've got another y right there. So I'm going to times my 3 and my 3 to get 9. There's only one x, but there are 2 y's. So I put 2 on my y. Okay, so we would write our final answer. Our final answer would be negative 6x squared y plus 9xy squared. So you have to draw those little hidden baby ones? No. But is it wrong if you show them? No, it's not wrong. Okay? So that will be our final answer for that. Okay? Let's move on and see how we continue. How do we do it if we've got binomial pairs? So now we don't just have one thing in front of brackets. We've got more than one thing. All right, let's take a look at how we do the FOIL or area diagram. So FOIL we know is first, outer, inner, or last. So you can do first by multiplying first terms, the outside, you can do the inside, and then you can do your last terms. So what I call the smiley faces are the O and the I, because your O and the I, after you multiply them, you have to add them together. If we do the area box, they're the ones that are sitting diagonal. So let's see what we write, what we end up with when we write our area diagram. So each one of them gets a box. So I've got my 2x and a positive 5 on the left, and then I get a 3x and a negative 4 on top. Okay? So now what I'm going to do is I'm going to multiply my coefficients, and I add exponents on the variables. Okay, we multiply our coefficients, we're going to get 6, and we add our x's, we get x squared. Multiply negative 4 to 2, we get negative 8, throw the x beside it. Over here, we're going to get 3 times 5, which is our 15, and the x goes beside him. And then we get negative 4 times 5 to give us negative 20. Now we look for like terms, anything that can be added the same. So it needs to have the same base and exponent. Bases are your variables. So these guys have base x and base x, exponent 1s. I can add them together. And when I FOILed it, that would be my O and the I. That's your smiley faces for O and I. So now you can rewrite it together. Your final answer for question 1 is going to be 6x squared plus 7x minus 20. Okay? Now, on number 2, it doesn't look like we have 2 brackets. But the number 2 on the outside, that exponent, is telling us we have 2 sets of that bracket. So if you can erase that 2 and just write the bracket again. So you've got 4a minus 5. B's. Okay, and then you do the exact same thing. I'll give you a minute and you can try multiplying that one. Okay, let's take a look and see what you got. 4 times 4 is going to give me 16. A1 and A1 gives me A squared. I got hiding ones on my A's. Negative 5 times 4 gives me a negative 20. I have two different letters, A and B, so they get just stuck side by side, AB. On the left, bottom left, I've got 4 times negative 5, same thing, negative 20, and I stick my AB beside it. And then I get a negative times a negative, which is going to give me a positive 25. And I've got B1 and B1 is going to give me B squared. Now again, you add like terms. Your like terms are the ones diagonal usually, and yes, they are again. Now, good question. Do you add the exponents on them when you're adding them? No, you do not. You just add you add the variables, add the coefficients in front of the variables. The variables just get stuck side by side written next to them. So our final answer is going to look like this. 16 A squared minus 40 AB, because 20 and 20 is 40 and it's a negative, plus 25 B squared. Okay, that's what we get for a final answer. We've got 2 on the bottom of the page. Give those a try and push play when you're ready. Let's see how you did. When we multiply these ones out, we've got 3x and a negative 7. We've got 2x and a negative 9. 6x squared minus 14x minus 27x, and I'm going to get a positive 63. You can rewrite your answer, 6x squared minus 41x plus 63. How'd you do? Who got that one right? Good. All right, let's take a look at B. B is actually called the difference of squares. How come? Because they're identical, but they're opposite signs in the middle. Okay, when you've got opposite signs in the middle, things change. Here we go. So I've got my 3x and negative 1, 3x and positive 1 to give me 9x squared minus 3x plus 3x, and negative 1 times positive 1 gives you negative 1. When I add these together, my like terms, they give me 0, so they disappear. You're not going to write them down at all. They completely disappear. So the final answer is only going to have the 9 and the negative 1. Okay? So your final answer here is 9x squared minus 1. Okay? Let's move on and figure out how we do all that with radicals. So doing the exact same thing with radicals. So when we're multiplying radicals, we do have a specific rule we're going to follow. So a couple rules here. In order to multiply, they have to solve or answer a couple conditions. The first is the index has to be the same. If the index is different, you can't multiply them. The indexes have to be the same. So you can never multiply a cube root to a fourth root or a cube root to a square root. Their indexes must match. Okay? Then you would multiply the coefficients, so numbers out front, and then you multiply radicands. So the numbers out front multiplied by the numbers out front. So coefficient times coefficient. Numbers underneath, radicand times radicand. And that's how we multiply them. And then we always simplify our final answer into a mixed radical. You never leave it as an entire radical or a radical that isn't simplified. You must simplify always. Okay, so first of all, what we want to do is we want to see, are we even able to multiply these? So again, one condition, same same index. So we're looking in the checkmark card. Do these guys have the same index? Yes, we can multiply them then. Do these guys have the same index? No. So we cannot multiply them. Do these guys have the same index? Yes, so we can multiply them. And we check over here, cube root and square root? No, we cannot multiply that. Okay? So now we're going to do some examples and see how this actually works. Okay, on the bottom of your page, we have root 6 times root 7. Well, we only have a hidden 1 in front of each of those. So 1 times 1 just stays 1. You can hide, I don't need to multiply them. I'm going to multiply my 6 times my 7, and I'm going to get root 42. Then I look and see, does root 42 break down, and does it divide by perfect squares? Well, let's check. Does 42 divide by 4? Nope. Does it divide by 9? Nope. 16? Nope. 25? Nope. 36? No. So this guy is broken down as low as he goes. Okay? Now we're going to do number 2. With number 2, I'm going to multiply my 8 times my 8, and you're going to get root 64. Well, what do we know about root 64? It's a perfect root. So then we actually solve it. So when you take the square root of 64, you get 8. You actually really do solve it. Okay?
And is that the answer?
That's your answer, yeah.
Will they ever give you both?
Pardon me?
Will they ever give you like both? Where it's like 64 and a 2?
No. They only will give you one. Or unless they're saying which one is the false statement, they'll give you the 2 true ones. Okay? All right, on number 3 we see here, the little 2 outside means I've got 2 of those brackets. So I'm just going to write them down. Negative 5 root 3 times negative 5 root 3. Now, I've got mixed radicals. The rule is you multiply coefficients times coefficients, and you multiply radicands by radicands. So that's going to give me a negative 5 times negative 5 will give me a positive 25. 3 times 3 is root 9. Now I solve further if I can. What do we know about the square root 9? It's a perfect square. So this will come down. I solve my root 9, which is 3. When they sit side by side, they may multiply. Now I just multiply 25 times 3. My final answer will be 75. Okay? So that one loses all his radicals, just like number 2 did. Okay? We solved it, and we ended up solving it completely with no radicals have in the answer. And that's okay. Now let's try number 4. Number 4, same rules apply. You're going to multiply the numbers in front, the coefficients, and then you multiply radicands. So I'm going to get negative 10 root 18. Now root 18 can break down. Root 18 divides by perfect square 9. So now I break 18 down into a mixed radical. So the 10 comes down, my negative 10 in front, and it breaks down into root 9 times root 2. So that's going to give me negative 10 comes down. The root of 9, which I know is 3, comes down in front, and my root 2 gets stuck beside them. To solve my complete answer, all I do now is I multiply those 2 numbers out front. So I'm going to multiply the 10 and the negative 10 and 3 to give me negative 30 root 2. That's what number 4 gives us. Negative 30 root 2. Okay? So at this step here where I was at negative 10 root 18, the 18 breaks down. You cannot leave it like that. That is not simplified. So in a multiple choice question or an example on a test, this negative 10 root 18, that could be one of the possible choices. But it's not an answer. How come? It's a possible simplification, but you want the simplified answer completely. So your simplified answer is going to be negative 30 root 2. All right, let's take a look at the cube roots on number 5. Just because they're cube roots doesn't mean we do anything different. We do the exact same steps. So at number 5, I'm going to have, there's a hidden 1 in front that multiplies by 4 to give me a 4. Then I multiply 12 and 5 to get cube root 60. Now I check. Does cube root 60 divide down by any perfect cubes? Doesn't divide by 27. Doesn't divide by by 8. So this is my simplest form. It won't go any lower. That will be my answer. All right. Let's try this example. Now we've got an example. But for the perfect square, it needs to divide by a perfect cube. Okay, because it's got a cube root. Okay, so how are we going to multiply a single term by multiple terms? I could have a ton of things in brackets. How do they multiply together? Same rules apply. I'm going to multiply my 3 root 2 to both of them in the brackets. So I'm going to take them separately, and I'm going to use an area box again. The area box seems to work very well. So 3 root 2 goes in front, and each of the ones in brackets gets a box on top. So 4 root 3 and negative 2 root 5. They each get a box on top. Now when I multiply, same rules apply. I multiply coefficients by coefficients. So this is going to give me 4 times 3 is 12. 2 times 3 is root 6. So I get 12 root 6. Okay? So slowing that step down, I'll just slow it down for you. what did I actually do? I took 3 times 4 to give me 12, and I took 2 times 3 to give me 6. Okay, then I put it in a radical to give me 12 root 6. So now we're going to do the exact same thing for the next part. So I'm going to take my 3 and times it by the negative 2, and I take the 2 and I times it by the 5. So that's going to give me negative 6 and a 10. So now I put it in the radical. I'm going to get in front negative 6. Underneath, I get my 10. So you get negative 6 root 10. Now you string it together and write it side by side. So my final answer out of the box is going to look like this. 12 root 6, and the negative 6 root 10 gets written right beside them. Now I check my radicands. Okay, I check the 6 and I check the 10. And I check and see if they're in simplest form or if they can be broken down further. These are in simplest form.
Why wouldn't you add them?
You cannot add them because remember they have different radicands. We can only add them if they've got the same number underneath. Okay, that was our adding and subtracting rules. Okay, you got a couple minutes to look at those. So let's take these up. When you multiply this through, do not forget, you need to multiply radicand times radicand. And then the numbers in front by the numbers in front. So this is going to give us 28 root 10. And I multiply my 4 root 2 times my negative 3. That's going to give me negative 4 root 6. Now I check my 10 and my 6 and I see if they go any smaller. They don't go any lower. I can't break them down. So that would be your final answer. Okay? Let's take a look at the next one. When you've got it in a box, 2 root 3 goes on the outside, root 12 and minus root 7 goes here. So, again, you're multiplying numbers in front to the numbers in front. So 2 times 1 is 2, and then I'm going to get 12 times 3. It's going to give me 36. So this is going to give me 2 root 36. But what do I know about the root of 36? It's a perfect root. If you actually hit root 36 on your calculator, it solves it to be answer 6. So you solve that, he becomes a 6. The 2 is attached out front, so he's times into it, so it's 2 times 6. So the answer for that box is going to give you a 12. Okay? Then we do the other box. So we're going to take the negative 1 times 2 to give me negative 2, and I take my 3 times my 7 to give me 21. Okay, 3 and 7 are under the radical sign, so they have to stay under your root sign. So you're going to rewrite that as negative 2 root 21. Now, does 21 divide by a perfect root? Nope. So he is by himself. You just write him next to the 12, minus 2 root 21. That will be your final answer. You cannot go any further. Now we're going to do the exact same thing with FOIL. Here's how they did it with FOIL. Again, it means multiply first terms. So we're going to multiply first times first. And the only thing we can do there, the 3 does not multiply to the 5. How come? Because the 3 is not under a root sign. The 3 is going to multiply to the hidden 1 in front of the 5. So that's what we're going to get over here, 3 root 5. Okay? Then for my outside terms, I have 2 radicals, so you multiply the numbers underneath, you're going to get root 30. The inside, there's no radicals at all, you just multiply 7 and 3 to get 21. So that's where I get these numbers. And then my last terms. The last term works like the first term. The 7 doesn't have a radical, so he can't multiply by the 6. He multiplies by the negative 1 in front of him. So you're going to end up with negative 7 root 6. Okay? That's how that was simplified. Now, none of these, if you take a look at these ones the way they sit, none of them are like radicals. Like radicals mean they have the same number under the root sign. None of them have it. And when you break them down, you can't go any further. These are already broken down into simplest form. So now you would just write it left to right. Okay? You string along. Does it matter what order they go in? No. It gives you smaller root to bigger root, but it really doesn't matter. Okay? Any questions on that?
Couldn't you do the boxes for like
Absolutely. They're just showing FOIL. I'm going to do the next example with the box. Okay? Absolutely. So they FOILed here on top of example 4, and we use the exact same example on example 4, and we use the area box. So we get the exact same answer using the box as we do with FOIL, okay? You get the exact same answer, okay? Either way you do it. Let's try a couple examples together. So we're going to do letter A. So we're going to open up area box for ourselves here. And I'm going to put on the left-hand side 2 root 3 and 3 root 2. On the top I've got root 3 and a negative root 2. Does it matter which one goes on the left side and which one goes on the top? No, it doesn't matter the order you put them in. Okay? And now I multiply the same way I did before. Coefficient times coefficient, radicand times radicand. So out front times out front, underneath times underneath. Yes?
So this one, do you solve that first and then
Abs.
to that?
Well, you can't solve these. There's nothing you can solve in there, dear.
You solve or you do the thing in the bracket and then you do the other one? Like, 'cause there's 3 right now.
Okay, let's do the multiplying. So, the root 3 has a hidden 1 in front, so I'm going to take 2 times 1 to give me 2. Then I'm going to take root 3 times root 3 to give me root 9. So this will give me 2 root 9. Now, what do I know about root 9? It's a perfect square. So I'm going to solve him. So 2 root 9 is going to give me 2 times 3, which is 6. So this first box is going to give me 6. So 2 root 9 equals 6 in that box. And it's because of this. Okay? Yeah. You're a step ahead? Okay. So now what we're going to do is we're going to multiply the next step. So the 2 root 3 we're going to multiply by the negative 1 root 2. So 2 times our negative 1 gives me negative 2. Root 3 times root 2 gives me root 6. So this is negative 2 root 6 is what I get. Over here I'm going to get 1 times 3 to give me 3. I'm going to get root 3 times root 2 to give me root 6. So this one gives me positive 3 root 6. Now I'm going to do my last one. You're going to times 3 times the negative 1 to give you negative 3. And root 2 times root 2 to give you 4. So this is going to give me negative 3 root 4. But again, what do we know about that root 4? It breaks down into a perfect root. So we're going to have negative 3 timesing by 2 to give us a negative 6. So this one here is going to give us negative 6. So if I write it all out, I don't have room besides, I'm going to write it underneath. Yeah.
Cause like the 2 terms and go how think about the 6 of this is negative 2 like on this like 6.
Yeah.
3 with 6.
Yep. No, we're at the point now where we have to add the like terms.
Oh, you got it.
Yeah, you add them together. So when we write everything out, we're going to write each box side by side. So we're going to get 6 minus 2 root 6 plus 3 root 6 minus 6. That's what each of our boxes gives us. Now with it all strung out, we can see what we can do. We're down to adding and subtracting. So what we do is we group the things together that are the same. So root 2 and root 2 match, or sorry, root 6 and root 6 can match. So I'm going to add the numbers in front of them. So I've got a negative 2 and a positive 3. That's going to give me 1 root 6. And then I take a look at my negative 6 and my positive 6. Well, 6 minus 6 is 0. So do I have to put plus 0 at the end? No. If it's 0, it disappears. Do I have to show the hiding 1 in front of root 6? No. So our final answer for this is just root 6. Okay? Okay, just root 6. Okay, I want you guys to go and try letter B. You guys try letter B, push pause down, push play when you're ready. Okay, taking a look, almost everybody got this question identical. That's not big enough. Okay, I'm going to make a giant box so I can see what I'm doing in every box here. So, here's my box. Big box. So, I've got 2 root 3 and a negative 5, 2 root 3 and a positive 5. 2 times 2 is 4, I get 4 root 9, but I can take the root of 9. The root of 9 is 3. So I take 4 times 3, that gives me 12 for that box. Now I've got negative 5 times 2 is a negative 10 root 3. Down here I get positive 10 root 3, and over here I'm going to get negative 25. Now if we look at our like terms, those cancel out and that gives you 0. So they just disappear. So your final answer is going to be 12 subtract 25, which is negative 13. Okay? All right. The next example is talking about a square. If it's a square, that means both sides are the same. So it wants you to take this one and multiply it by itself. So if we take a look at the next example, you're just going to take this guy and multiply it by itself. So you're going to get 2 root 18 minus root 27 times by 2 root 18 minus 27, or root 27. Now those are huge numbers. It's easier if you break them down. Okay, it's easier if you break them down. Does it matter? You'll break them down in the end anyways. So sometimes it's easier to start with them broken down. Okay? Do that question, push play when you're ready. Okay, you've got a couple minutes to look at that one. Let's take it up together. So, because there's a subtraction sign in between them, you need to take the left-hand side and the right-hand side and solve them separately. So, on the left-hand side, I need to do an area box. So I'm going to have root 3 plus 8, and I have 2 root 3 and a negative 1. So this is going to give me 2 root 9, and I know the root of 9 is 3, so that's 2 times 3 to give me 6 for that box. Now I've got 8 times 2 to give me 16. I put the root 3 beside them. And over here I've got a negative 1. I just multiply it by the positive 1 in front of the root 3 to give me negative 1 root 3. Do I have to show the 1? No, he can hide. Let's look at the next box here. I've got 8 times negative 1 to just give me negative 8. Now I look at my like radicals. Do I have any like radicals? Diagonally, yes I do. I've got 16 and a negative 1. They both have root 3, so I can add the coefficients together. That's going to give me 16 minus 1 is 15. So my final answer for the first half of the question is going to simplify to 15 root 3 and minus 2. Where do I get the minus 2 from? I get 6 minus 8 gives me my minus 2. So that is my first half of my example. Let's do the second half and see how we do. Another area box, only it's going to be a 1 by 2. So I've got root 3 in front and 7 root 3 here minus 4. Okay, so when we multiply here, we're going to get 7 times by our 1 to give me 7. Root 3 and root 3 gives me root 9. Again, I can take the root of 9, so I get 7 times 3, which gives me 21. Then I multiply my negative 4 by the hidden 1 to give me negative 4 root 3. So now I write the equation again. I write it with the left half, which I received first, which I figured out was 15 root 3 minus 2. And now I'm going to subtract what I have here and what I found. So I found 21 minus 4 root 3. Okay, now what we do is we multiply that negative 1 in front of the bracket. That's why I had to put the answer I got on the right-hand side back in brackets, because there's a subtraction sign between them. Now, if there's an addition sign between them, I wouldn't need brackets. I could just add like terms. Because it's a subtraction sign, I need to multiply the negative 1 in. All it's really going to do is change the signs on the inside of that bracket, but it also removes the brackets for me. So now I'm going to get 15 root 3 minus 2 minus 21 plus 4 root 3. At this stage, this is where I group my like terms. So I've got some root 3s and root 3s. I add the coefficients in front to give me 19 root 3. And then I take a look at my constants. They don't have a variable or a radical with them. I add them together. That's going to give me minus 23. That would be my final answer. That's as far as I can go and simplify. Okay, back to our practice question. Like I said, we're going to break root 18 down first, and we're going to break root 27 down. They both break down. I'm going to break them down so they're smaller numbers to work with. So this is going to give me 2 times root 9 times root 2. The root of 9 is 3. That multiplies by the 2 who's already in front. Then my root 2 comes beside. So that's going to give me 6 root 2. Then I take my root 27. That's going to break down and give me root 9 times root 3. The root of 9 is 3. So that's going to give me 3, and the root 3 sign is going to come right beside. Now I stick that in the bracket. So this actually simplifies, and I'm going to use 6 root 2 minus 3 root 3. That's what this becomes. So now it says you've got a square. If you've got a square, that means both sides are the same, or all 4 sides are the same. So for my square here, every single one of those sides is equal to 6 root 2 minus 3 root 3. And if I want to find the area, well, area is just length times width, so I need to multiply that by itself. So now I'm going to take 6 root 2 minus 3 root 3, and I'm going to multiply it by itself. 6 root 2 minus 3 root 3. Okay, I'm going to use an area box. You got a few minutes to work on these, so follow along and check your work what you did before. So, my 6 root 2 minus 3 root 3, 6 root 2 minus 3 root 3. Okay, 6 times 6 will give me my 36, timesing by root 2, and root 2 gives me root 4. Well, that gives me 36 times 2 because the root of 4 is a 2, and the root sign disappears. 36 times 2 gives me 72. So my first box gives me a 72. No more radical signs, they disappear. Then I'm going to take a look at my next terms. I've got a negative 3 timesing by 6 to give me a negative 18. I multiply my root 2 and my root 3 to give me root 6. That does not break down any further. It's as far as I can go. On the bottom left, I get the same thing. I get 6 times negative 3 to give me a negative 18. And I take root 2 times root 3 to give me root 6. Moving to the last term. I've got negative times a negative is a positive 9, because 3 times 3 is 9. Then I get, again, root 3 and root 3 give me root 9. Now, root 9 we know breaks down into 3. The 9 in front times is by my 3 to give me a positive 27. Now I string things together left to right to see what my answer becomes. So my final answer is going to become negative 18 root 6 plus negative 18 root 6. That's not how I write that. Negative 18 root 6 plus 72 plus 27. So that is now going to give me, I add my like radicals, add the digits in front, I'm going to get 18 plus 18 gives me negative 36 root 6, and then I'm going to add my constants that don't have variables or radicals, and I'm going to get 99. It's a positive 99, so I add the